Yeah, hello guys. Welcome to our channel Geeks for Geeks Practice. Before starting our today's lesson, can you just confirm that if I'm audible or not? Yeah, and is my screen properly? That means, am I visible and is my voice properly audible or not? Yeah, it would be great if you could just confirm me so that I can proceed. Okay, great. Fine. So today we are going to have a look at a question which was asked yesterday at the portal at Geeks for Geeks. It was problem of the day, okay, of Sunday. Like today it's Monday, right? So we are going to discuss the question which was asked yesterday. So let me share my screen. Let's have a look at it. Yeah. So the question says that there are certain pullers and thieves, okay? Like the very brief about the title, pullers and thieves. Let's try to go through the details of the question and let's try to understand, okay? What does it mean to say? So for that, let's go to the whiteboard, okay? Because that will help us in better understanding of the question. So yeah, let's see it over here. Pullers and thieves. Given an array of size n, okay, such that each element contains either a P for policeman or a T for thief. So just for making sure that we understand each and every line, I will try to explain it with the help of this input. Okay. So as you can see over here, we have an array. Okay. This is an array where each element is either capital T, which stands for a thief, or capital P, which stands for a policeman. Right. What we need to do, we need to find maximum number of thieves that can be caught by the police. Okay. So the question is saying that we need to find out what are the maximum number of thieves that can be caught by the police. Fine. So what conditions do we need to keep in mind? Each policeman can catch only one thief. That's nice. At least we are clear, right? Like how many policemen could catch how many thieves, right? So in a way, it's nice that we are getting more clear with respect to the question. After that, a policeman cannot catch a thief who is more than k units away from him. See, whenever you read these kind of questions, try to focus on these words, okay? More than k units. When it says more than, it means equality is allowed. Okay, what do I mean by that is, I'll explain it to you, okay, with the help of this sample input. But for the time being, it means that a policeman will not be able to catch a thief who is more than k units. Means if a thief is less than or equals to k units away from a police, he will be caught. Okay, or rather, thief will be caught by the police. If it is greater than k, then police cannot catch that thief. Okay, so let's try to go through the first sample input and let's try to understand all of it. Okay, so it says that K is 2, okay, which means police can catch a thief which is less than or equal to K units away from the police, right? So if you carefully observe over here, we have 3P and 3T. So there are 3 police and 3 thieves. Now, one thing which is not mentioned in the question, but it is pretty much implicit, that police can catch thieves from any of its side. Okay, what I mean to say is, let's say we take this police, then this police can look towards this side as well as towards this side. Okay, like we can catch thieves on either side. All right, fine. Now let's have a look at like how we have reached to this output three. Okay, so let me just clear this area a bit. Let's try to take this first police, okay? The value of k is 2. So if I jump 2 units, okay, if I hop 2 units, this is the maximum reach, okay, this is the maximum reach of this police in this left region, and the maximum reach of this police in right region is still this much, okay. So over here we have so many choices, like we have for this police we have this choice, this as well as this, right? Like police can catch any of these three thieves. But it is mentioned that each policeman can catch only one thief. All right, no problem. So let's say this policeman catches this thief. Okay. So what we have right now, like earlier we had T T P P T P, right? Now this policeman has caught this thief, so this is gone. Right. Now let's say we take this one, okay? This policeman. If you take this policeman, then again this policeman can catch this thief, right? Because this is also at a distance of 2 units away. Okay. Similarly, this policeman can catch this thief because it is less than equals to 2 because the distance is just 1, right? So in total we have three thieves that can be caught by the police in this particular sample input, right? So I hope the question is clear to you. If you have any doubts, you can ask me in the comment section. Okay. For the sake of explanation, let me take one more sample input. Okay. Let me explain it to you with the help of this input. Okay. Let me clear the screen. So over here also we'll do the same thing. We have this police, right? Value of k is 3. So what is its reach? 1, 2, 3. So at max, to its right, it can go till this point. To its left, there is nothing, no problem. So yeah, that is how it is. So let's say over here, as we could see, this police has the choice to either catch this thief or this thief, right? So let's first try it out with this thief. Let's see what happens. Okay, so let's say let's write it again. P T P T T P T. So if this policeman catches this thief, these two are gone, right? Now again I have the choice, right, with this police. It can go till here. So it can catch either of these two thieves. Left side, anyways, we don't have any thieves left. Okay, so let's say this policeman catches this thief and we are done, right? Similarly, we can have this thief caught by this police. So the output is 3. Alright, so I tried to explain you this question with the help of two inputs and their corresponding outputs. If you have any doubt till now in this question, I'm just talking about the understanding of the question. You can let me know in the comment section. Okay. All right. So as I see that you don't have any doubts till now, let's try to frame the logic. Okay. Let's try to frame the logic for this particular question. See, these kind of questions when they ask you to find maximum, minimum. Okay, there can be approaches where you might go with like finding out a particular algorithm, okay, which will suit your question. Okay. Anyways, generally we do that only. But when I say a particular algorithm, I mean that if you have solved these kind of questions before, or is there any variation of the question which you have solved before, okay, then you can apply that algorithm. Okay. But to me, this question seems fresh if I am asked for the first time. Okay. So this is a kind of question where you need to apply greedy algorithm. Okay. Greedy algorithm, when I say what do I mean? So greedy algorithm says that you need to choose what is best at that particular moment. Okay. So let's try this question with the help of one such technique. Okay. So let's say I have chosen a greedy approach that I will always select my nearest thief. Okay, I will start from my left and I will always select the nearest thief. Okay, I will always select the nearest thief. Let's try it out in example, this sample input. Okay, let's try it out. So let's say this is my police. Okay, so nearest thief and one more thing, nearest possible. Okay, like if a thief is far away and far away in the sense it is exceeding the value of k, then that is not possible. Okay, even if there is a thief, but that is out of my range, right? So I cannot take that. So let's take a greedy approach to find out the nearest possible thief. Let's see if we can do that or not. So if I take this police, what is the nearest possible? See, there is bandwidth till here, right? Because k is 3. So the nearest possible is this thief, right? That's great. We take these two. This is done. After that, we have P, T, T, P. Again, for this P, nearest possible is this T. Done. Now, as we move from our left, okay, towards this, the very first P we find is over here. Okay. Now, for this P, the axis will be on either of its sides. So, nearest possible is this T. So, I see that I'm able to get the output 3 from the greedy approach that we have chosen right now for this sample input. But that is not how it works. Okay, let's try it out for one more. Okay, let's try it out for this for sample input. See, in case of greedy solutions, mostly people go with the help of test cases and try to generalize as much as possible. Okay, okay, so let's go with the first sample input. So if we do the same thing, what is the nearest possible for this police? This T, right? Fine, I take these two are gone. I have this police now. What is the nearest possible? This T, right? So these two are gone. Now for this P, what is the nearest possible? None of them, because this T is far away and we have exceeded the value of k equals to 2. So what output we are getting? We are getting 2, right? Which is obviously not the correct output. So I can say that this greedy approach, what we have chosen, is wrong. Okay, we cannot proceed with this. Fine, no problem. Let's try to take some other greedy approach. See, a lot of you might argue that why are we going with test cases? Okay, why don't we have some general algorithm? Why we are doing like this? So I'll come to that. Don't worry. Usually, I'm trying to teach you how to approach greedy solutions. Okay, so greedy solutions are approached in this manner. You first devise your algorithm. Okay, you try to apply it on test cases, and later you generalize as much as possible. Okay. So let's take another greedy approach. Let's say we now choose farthest possible thief. Okay, farthest possible thief. Okay. See, because the definition of greedy itself says that you will be doing what is best at that particular moment. Okay, you are not going to see in your future in the future. Okay, in the future, in the sense after some allocation of police and things, you are not going to think it in that manner. Okay, so you are going to think at that particular moment. So let's say for this P, as I said, my range is till here as well as on the right side till here. Right? So I am allowed to choose this as well as this if I take the farthest. Let's say I choose this one, okay? Let's say I choose this one. So how does it becomes? T T T P T P. So if I choose this thief, this is gone. Okay, this is gone with this P, right? For this P, this will become the farthest. Sorry, yeah. For this P, this will become the farthest, right? One, two hops. So I chose this. Now, for this pay, I don't have any possible farthest thief because this is exceeding my value of k. It is exceeding that range. So the answer becomes 2 for this one, which is wrong because the output is 3, right? So this greedy approach is also wrong. All right, not an issue. But at least we understood something from these two approaches that neither my nearest or farthest is going to work. Okay, that is for sure. Like what I was doing, I was taking nearest thief or farthest possible thief, right? From the corresponding police present at that point of time in my iteration, right? So it's not working. But I think what we saw that an approach, like the nearest one, was working for this one, right? And farthest one did not work for this. Let's say farthest one works for this or not. Okay, let's try it out. Like yeah, nearest one did not work for this one, right? Okay, the first input, but nearest one worked for the second input. Fine. So let me write it down because I think I said the opposite thing. Nearest one worked for the second approach. Okay, worked for second approach. Second input, I mean to say. Nearest one worked for second input, and farthest one, I guess it worked for first input, right? Uh, we'll see. Hold on, let's see it again. Why to get confused? But at least we are sure that nearest one worked for the second approach, right? So let's see for the farthest one. Let me clear this area just a second. I see that there is a comment. How can make sure that this particular police catches that particular thing? All right, I'll come to that. I'll come to that. Let me just start developing the algorithm. Okay, I'll come to that. So the very first video approach was catching the nearest possible thief. Okay, and the next video approach was catching the farthest possible thief. Okay. Yeah, I'm just writing it because I think that I have said something opposite in between. So let's just do a quick dry run and see. So as I said, the nearest one was working for second. Let's just cross check, okay? Uh, because I think I have said something opposite. No issues. We'll see it again. You can also go back to the video and watch it. But in brief, I'll explain it once again. So if I take the nearest possible thing, okay. So in the first one, in the first one, what was happening? Like for this P, I took this T. Okay, this is gone. For this P, I took this T. This is gone. I was not able to take any particular T for this P, right? So that's the reason we were getting wrong output in the first sample input. Okay, so let me write that also. That first did not work. Second worked. And for that, let's cross check second as well. So second, if I take, we have this P. If I take nearest, I am done with this too. Okay. For this P, I'm done with this, and for this P, I'm done with this. Great. So I'm getting the output 3. Now let's do the same for the farthest ones. So for the farthest one, if I go with this P, I told that I can either take this T or this T, okay, because this P has a range on either of its sides, 2 units, right? So yeah, that's what I'm saying now. So let's say I take this T. So this P and this T is gone. For this P, this T is gone. Now for this P, I cannot take this T, right? So that's what I see that the output is coming out to be 2. Okay. So this did not work for here also. Okay, let's try to choose this T. Okay, I hope you are able to follow. Like for this P, we had the choice of this thief or this thief, right? Because I can go to either of the areas. So let's say I am going to this area. Okay, so if I take this one, okay, then I am done with this. For this P, obviously I'm going to take this. Okay, father's P. For this P, I'm going to take this. So now we are getting the output. Fine. So if I take this T, we are getting the output for the first one. with an added constant that if we have more than one choices of thief, we need to devise some way to take the correct thief. Okay. So I am assuming right now that when I took this thief for this P, I was able to get my answer for the first one, right? So it worked for the first one. So let's see for the second one. For the second one, this P, as my access is still over here, so I'm going to take this T. Okay. This P and this T is gone. For this P, obviously I'm going to take the farther one. So yeah, let me take this one. Okay, so this is gone. This is gone. Now my reach is 1, 2, 3. So obviously I cannot go till this T. So it's failing, right? So it did not work for the last police. So for 2, this did not work, right? Great. So what we saw that if we are tackling anyone, okay, tackling anyone in the sense uh, means using any one approach, like any nearest of others, it is working for some inputs and it is failing for some inputs, right? So somewhere we are close to the algorithm because at least it worked for some of them, right? But at the same point of time, it is wrong because it was failing for some inputs. So what you need to do, you need to take a positive side from here that somehow you need to figure out why you were getting correct answers for few inputs in the approaches which you took. Okay. So what I observed is what we were doing wrong is we were fixing our police. Okay, we were fixing our police, and we were figuring out which teams to choose. Okay, in both the approaches we did the same thing. I think that's where we are doing wrong. We don't need to fix police. Okay, we don't need to fix thief. We need to somehow find a relation between them. Okay, relation in the sense somehow try to devise an approach where we are fixing neither of them. We are just looking at inter distance between them, okay, and finding out if that's possible or not. Okay? No need to fix any police or anything. Okay. So I'll just show it to you in a moment how we can do that. Okay. Yeah, and to answer that question, how can we make sure that the particular police catches the particular thief? That we will see when we go through the code, right? Because I believe that's the implementation part. Because you can use flags, okay, or you can remove that particular thief or that particular police from that particular array. Okay, that means that you have already taken care of, or the computation has already been done. So I'll come to that when we visit the code section. Okay? Fine. So as I said, let's not go with fixing the positions, okay, of police and finding out thieves. What we should do is let's try to find out the interdistance between them. So for that, just a second. Uh, Let me take the fresh area, okay? Yeah. For that, let's say I take this sample input, okay? So I will capture my positions, okay? My indices or index of array. If I do the indexing 0, 1, 2, 3, 4, 5, right? So where do I have police? I have police as at 2, 3, and 5. Okay? Great. After that, let's take a similar array for thieves. Okay. So for thieves, I have 0, 1, and 4. Okay. What we'll do is, see, now we are not going to fix anything. Okay. We are going to use these two arrays. Okay. And we are going to keep on checking the distance. Okay. Checking the distance between them. For example, let's say I have two pointers. Okay. This is the start of police. Okay. And this is the start of the positions. I subtract this from this, okay? Means I will be doing either 2 minus 0 or 0 minus 2. I don't know. I'll just be taking the absolute value, okay, at the time when I'll hold. I will check whether this absolute value is less than or equals to my value of k or not. Okay. If that is the case, I am sure that this could be one of my possible answer, right? Because police is able to catch that thief, right? If that's true, over here that is true, right? Because 2 minus 0 is less than or equals to 2. It's obviously not less than, but at least equality is there, right? So what we'll do in that case, we will increment our pointers to 1, 1, means by 1, and in our answer we will have one store, because till now we have found out that there is at least one possible pair of police and thief, okay, that where a police has caught a thief. Now I have over here 3, 1. Okay, so we'll do the same thing. This is again satisfying my criteria, so I'll make my answer to 2 and I'll increment. I'll increment. I come over here. I come over here. I've implemented both of them. See, don't worry, I'll take more sample inputs where we will see what will happen if this condition fails. Okay. So don't worry about that. We'll see all of them. So now we have 5 minus 4, which is again true. It is simple input. Okay, so no issues, we'll see. So this is again true. So we make our answer to 3, and once size is exceeded, so we return. Right? Let's try to do this for this particular sample input. Okay. See, greedy questions at times becomes very tough in interviews because uh, you are coming up with different algorithms, okay, at your point, but you don't know like which one will work, which will not will work. So if you practice more, you will get a feel, or you will eventually realize that you will be somehow able to generalize your greedy solution. Okay, it seems easier at times, but at times these are like the turning point of interviews. Okay, so because that's interesting thing with beauty solutions, you don't have any particular way provided to you. You yourself at that point of time has to come up with some greedy approach, okay, which you think will work, okay? And you have to show that, or you have to generalize that in some way, okay? So that's the reason I told why it becomes tough at times. So let's proceed. For p we have 0 to 5, right? 0 to 5. And for T, I have 1, 3, and 4. Okay. 1, 3, and 4. Good. So this time the value of k is 3. So 0 minus 1. Okay. If I take absolute value, it is less than or equals to 3. Okay. This test case will also not lead to any faults, means where this value gets changed. But no issues. I'll take one more input after this, and I'll make sure that we fail at some criteria, okay, where we are doing this comparison, and we'll see how it works. Okay? So let's at least first complete this input. So we come over here again, 2 minus 3, its absolute value is less than or equals to 3. If I proceed forward, again 5 minus 4, okay, its absolute value is again less than or equals to 3. So I have my answer because I have finally exceeded my range. Let's say in this particular input only, I had, instead of 3, I had, let's say, 4. Okay, let's say I had 4. Okay, if I take 4, things will become more straightforward. Let's say I have 1. Okay, let's say I have 1. Or even if I take 1, I'll get that output because I see all the subtractions are leaving the absolute difference as 1. So let me take a totally separate input, okay? Totally separate input. So let's say my given array is somewhat like I have thieves, okay, initially. Then I have police. Okay. 3 thieves and 3 police. Okay. Value of k is given as 1. Okay. Yeah. Let me do the indexing. 0, 1, 2, 3, 4, 5. So if I take my P, this becomes 3, 4, 5. If I take T, it becomes 0, 1, 2. Right? Now let's try to follow the same approach. Until now, we have seen that our discussed approach has worked for both the inputs. Okay, I have taken one more input and let's see if this works over here now. So let's do the same thing. Let's do 3 minus 0. Okay, is it less than or equals to 1? No, that is false. That is false. So what to do in this case? Now here comes the what would I say? The most important part of today's lesson. Okay, here you need to decide what are you going to do if your condition fails, okay, where you are not able to be in the range where a thief can be caught by the police. So let's have a look at it. Your pointers are over here, right? Like for the police array, it's at the first index, and for thief array, it's also at the first index. So my greedy knowledge says that I will compare these two, okay? So I will compare 0 and 3. Okay, why I am comparing? Because in future, okay, in future I'll not see exactly in future. I'll be comparing because at the moment, okay, to be more precise, in future will not make sense. At the moment, what I need to do, I need to somehow decrease this range. Okay, I need to somehow decrease this range. So I have only one choice. Okay, or I would rather say I have two choices. Okay, let's see both of them. So first choice is that either I can push this forward. Okay, either I can push this forward, or I can push my thief pointer to backward. Okay, so we are going to follow the approach where we are going to push this police pointer forward in this scenario for the time being in this scenario. Because we are trying to devise a general approach. Okay, an array is scanned from left to right. Okay, so I'm trying to keep things standard. So in order to decrease this range, okay, in order to decrease this range from 0 to 3, I can either increment my police pointer or either I can decrement my thief pointer. Okay, so I am going to go with this approach. I'm going to increment my police pointer because decrementing my thief pointer, I don't think will help me. Okay. Oh, just a second. This is my police pointer. Okay. Sorry, my bad. This is police pointer and this is thief pointer. Okay. So I was just saying the reverse thing, but you got an idea, right? What we are doing, we have calculated the difference 3 minus 0, which we saw that it is false. Now, my greedy approach says that I need to somehow decrement this range. Okay. So what I can do, I can squeeze or I can shorten this range by either pushing things from this side or decrementing my police pointer in this case from this side. Okay, because police is at third position or third index, thief is at zeroth position. Okay, fine. Are you able to follow? Like till now, is everything clear? Like how we are going? All right. So I'll generalize in a moment. Don't worry. I'll stop saying police and thief after a moment. Okay. I'll generalize which pointer to implement, which pointer to decrement. Okay. So let me just have some space for that. Yeah. So I have 0. I have 3. I said that I am going to decrement this range. Great. So what I said, this is my, yeah, I'm sorry for saying this opposite, okay, before. Right now I have cleared that this is my police pointer and this is my thief pointer because thief is at index 0, police is at index 3. So I'm really sorry for whatever I told at that point of time, okay, which was the reverse. But no issues. Now everything is clear, right? I was just trying to give an idea how we are going to decrement the range. So what we are doing basically is we are comparing 0 and 3. Obviously 0 is less than 3. So whichever is less, I am going to increment that. Okay, I am going to do a plus plus in that. So I have told this. Now let's see if this works or not. Okay. So 0 is less than 3, so I'm going to increment my 0, okay, to the next position. So if I increment my 0, I come over here, right? So my thief is now pointing to first index, but my police is still at 0th index, right? Police is still at 0th index. Now what I can do is I can again check whether 3 minus 1, okay, is it less than or equals to 1? It is still false. So I need to further decrement the range, right? So this was 1. If I further decrement, like if decrement the range in the sense, if I need to decrement the range, I need to increase my thief pointer, right? So I come to this. Okay, now this value becomes 2. So I check whether 3 minus 2 less than equals to 1. Yes. Although it's not less than 1, but it's at least equals to 1, right? So now this is becoming true. Now this is becoming true. We have one answer, okay? So in answer I have 1. And after that, we have seen that we have reached our final element in our thief pointer list. So no thieves are left. Okay, no thieves are left. What police is going to catch? Okay, so we end our answer over here, right? So this is an approach which we are going to implement. Okay, and if you have doubts in this approach, you can ask me in the comment section right now. Okay, I'll answer all of them. We could also have tried, instead of incrementing the lesser pointer element, decrementing the greater one, okay? But decrementing the greater one means that you are going back in your array, okay? Which is which might be already processed, okay? Which might be already processed. That police have already caught a thief, okay? Because we are traversing from left to right. So if things are clear, let me write in general, okay, what we are going to do. A pseudo code for that. After that, we'll see the actual code. So in general, we are going to have two array lists in Java or vectors in C++. Okay, I am trying to keep it general. Let's say we have two array, which is storing the positions. Okay, it will store the positions of first police array, then thief array. Okay, after that, we are going to run a loop. Okay, where the terminating condition of loop will be size of this p. Okay, this has not reached, means you have not reached till the end. Okay, you will keep two pointers. Let's say keep I and j for I. Let's say I'm referring to this p, or let's try to keep it more meaningful. Let's say I'm keeping start p. Okay, start police and start p. So we will be going to start of police is less than p dot size ampersand start of p is less than. Okay, let me write it full. Let me write it. Start of p is less than p dot size and start of t is less than t dot size. Okay. This will be our condition for loop. Now inside this start p and start t, both of them have the initial values as 0, right? If you remember, as we discussed in our logic, we are pointing to the initial ones. Now let me just zoom out a bit. Yeah. So if let's say take the absolute value, okay, math.abs, okay, positions, okay, start p and start t is less than or equals to k, okay. Like obviously you will get it from your array, okay. Like you will take p start p, okay, minus t start t, okay. Absolute value of it less than equals to k. Then you are incrementing your answer by one. Okay, initially let's say you have initialized your answer by 0. Okay, let me write it over here. You are going to do answer plus plus, as well as you are going to increment your pointers of thief and police. Okay, police and thief. Else. Okay, else. Now in else you have to check which one is less. Okay, okay. Else if start of P. Okay, okay. T of star of P is less than T of star of T. Okay, if that is the case, then what you are going to do? You are going to increment your start of P. Else you are going to increment your start of T. That's it. And at the end, when you are done with this while loop, you are going to return your answer. This is just a pseudo code. We will look at the exact code for this. Okay, so don't worry about that. I hope this is making sense to you. Like this was the crux. Okay, this region, because these things are pretty straightforward. Like if we are done, we are obviously going to implement both of them, right? So, do you have any questions till now, like with this approach? All right. Then what we can do is let's go to the code. Okay. So let me just zoom in. Yeah. So see, you won't find anything much new. Okay. Because whatever you are seeing on the screen right now, I've already discussed them. So you have two array lists. Let me change the color. You have two array lists. This is TH for thief and P for police. I am once traversing on my given input array, okay, and I'm checking if my character is P. Push that particular index, okay, push that particular index in my police array list, that is P. If it is anything else, obviously it will be T, right? If it is not P. So I will not check what is the other thing. I have just straight away pushed that into my thief array list. Right. Fine. So we have over here two pointers. Okay. Start of thief and start of police. I have my answer initialized to 0. Same while loop which I wrote on the screen. If start of thief is less than thief dot size and start of thief is less than thief dot size. This ampersand is very important. Okay, you need to make sure that you have not reached to end of any of the array list. Okay, because then only it is making sense. Because if thief then thief is finished or thief has been ended, where is what is the point? Okay, police catching that thief. Or if police is finished early, then where is the police that will catch the thief, right? So either way, it's not making sense. So if any one of them is, if both of them is non-empty, then only we are in this loop, right? Non-empty in the sense, if both of them has not yet finished, okay, I hope you get my point. If both of them has not yet reached to its maximum size, okay, fine. So let's have a look at further lines of the code. Okay. Yeah. So I'm checking initially my absolute difference between the elements present at ST and SP, okay, in corresponding TH and PRLS. If it is less than equals to, okay, doing my answer plus plus. Else if which one is small, okay, so I took the position at this particular, or rather I took the element present in the RLS and this particular index. Okay, similarly, I took the element in this RLS. So if this was small, okay, if ph dot get st is small, then I'm doing st plus plus. So if you remember, I was explaining example of 0 and 3, right? Okay, so this was police and this was thief, I remember, as far as I remember. Or it's okay, like let's do a dry run on this sample input. Okay, I think that will make things much more clearer. So it was this. Just a second, let me write this. Yeah, so this was the input. Okay. Yeah. So the indexing is 0, 1, 2, 3, 4, 5. Okay. So let's do it with this particular sample input. So initially in T I'll have 0, 1, 2, right? In P I'll have, or to be more precise, let's do it along with the code, like this is TH, okay, and this is my small p, right? So for TH I have 0, 1, 2, okay, and for small p I have 3, 4, 5. And I took the value of k as 1, right? Now, now if I do absolute of th dot get st, okay, that means st is over here, okay, by the way, st is at over here, sp is also at over here because I have initialized both of them with 0 and 0. So 0 minus 3, I was doing absolute value is 3, which is not less than equals to 1. This was false, right? So what we are checking after that? We are checking th dot get st. Okay, so th dot get. So what is the first value? Okay, get zeroth position. So I have 0, right? And p dot get starting pointer of police. Okay, starting pointer of police is at 0, so the very first is 3. Right? So if 0 is less than 3, increment your start pointer of 3. Like whichever is less, increment that. So my start pointer of 3 goes from here to here. Right? So what it basically did, it basically decremented my range. Okay, range in the sense in future I might be sure that okay now I this is what I was getting. So in future I might get something closer. Okay, or if I don't get closer, then what could happen? Then I will try to see which one is less. If at that point of time again P is less, okay, or if that point of time again TH is less, I will again increment TH. If P is less, I will increment P. Okay, I will seriously suggest you that you take some sample inputs and try run this piece of logic. Okay, you will get a better clarity. Okay, how things are happening. So yeah, as I said, we are going to increment and this comes over here. No, right? Again, we are doing 1 minus 3, which is still false. And still this is less. Okay, this is less. So we come over here, right? We see this 2. 2 minus 3, which is at least equals to 1, not less than. So this becomes true this time, right? This becomes true. So we do an answer plus plus, which was initially 0 if you see over here. So this becomes 1 now. Now we are implementing both the pointers. So it goes outside and this comes to its first index, okay, right, for the police one. We check this condition and this time this becomes false. We are out of this loop and we return our answer at the end. See, we are returning our answer. So I hope this code made sense to you, okay? And trust me, whenever you see solutions like greedy solutions, if it is not among the standard set of problems, you need to practice more. Okay? You need to practice more, then only you will be able to come up with these kind of approaches. Okay. Yeah. So this was the problem of the day that was asked on Sunday. Okay. That is 25th of April 2021. Yeah. Yesterday, I mean. Yeah. 25th of April 2021. So do you have any doubts till now in this piece of code? Let's try to compile this. All right. So the output is 2, which is correct. Let's try to sum it. So we get the correct answer for this. Fine. So I hope the question is clear to you. Okay. And everything was very much understandable and the logic was pretty much convincing to you. Okay. Sharing the code, like right now from here, I'm not advised to. But what I can do is like you can ask doubts in the comment section if you have any with respect to the code, or you can pause the screen, okay, at the at the correct timestamps, okay, like when I was explaining the code, and you can have a look at the code from there, okay. I would have shared the code, but I'm not advised to do so, so I'm really sorry I won't be able to do that. Okay. But yeah, I have explained line by line each line of the code, right? So I hope you won't have any problem in that. Yeah. Any other questions related to this particular explanation or logic? Yeah. I think there was some technical issues with respect to the audio. Just a second, like, and with respect to some of the comments also, like I'm seeing them right now. If we don't get the police or distance which is greater than k, then ignore that thief, asked by someone. So I hope now it is clear to you, right? After I have gone through all the logic. And like, is there any audibility issues still now, like, or is my voice clear? My name, no, I am not SK Sama. My name is Rohit Kumar. I am a course mentor at GeeksforGeeks. Okay, asked by Hardik. So yeah, guys, do you have any doubts in today's lesson? Okay, there's one more comment. Can we solve in bigger and square? Like for each thief, we will count how many police is less than equals to k and count plus. See, then you need to take care. Like let's say for a thief, you have taken a police. Okay, now you also need to make sure that same police is not picked up by other thief. Okay, so you need to keep a check over there. Okay. All right, guys. Then I think that's it for today. Like if you don't have any further questions, so I'll be coming up with the discussion of each problem of the day. Okay. In the next in the next live lesson, like for today, like today it's Monday, right? So I picked the problem of the day that was asked on Sunday, right? So tomorrow I'll be coming up with today's question, okay, and so on. We'll be discussing each questions in detail, okay, and I'll be adding more inputs to questions as well. Today, this was a very typical question. So I was not able to add much input because this is typical in its own way, right? For greedy solutions, you will have to come up with separate solutions, okay, separate algorithms. But when it comes to some questions, some category of questions, if there are, I will discuss the main question. Along with that, I will give you inputs on what other questions could be there on the same pattern. Okay. So today was not one such case because this problem is one of its kind. Okay. All right. So then let's meet tomorrow, guys. Okay. Thank you for joining Geeks for Geeks practice. We'll see you tomorrow. Okay.